Good afternoon to all of you. In today's meeting, actually, we are going to discuss crystal systems. So, actually, there was a French mathematician. Okay, there was a French mathematician called Bravais. Okay, there was a French mathematician called Bravais, Bravais. Now, according to Bravais, there are total 14 types of crystal systems, like all total. So, that Bravais said was that the 14 crystal systems, first you will have to identify them according to the position of the constituent particle, and then you have to identify them according to the geometry, and then you have to take combination of both. So, according to position of particles, basically there are three types: primitive, body centered, face centered, and there is end centered. So according to the position of the particles, there are four types actually: primitive, body centered, face centered, and end centered. Now first of all, what is primitive? Primitive means that the particles will be at the corners of a unit cell. This is called a unit cell. Okay, now what is a unit cell? Unit cell in a crystal system is the simplest unit, and the entire crystal is generated by repetitions of this unit. So unit cell is like a building block for the whole crystal. So if you keep repeating unit cell successively, you will get the whole crystal. So primitive unit cell means that the constituent particle will be at the corners. So 1, 2, 3, 4, 5, 6, 7 and 8. So when you say primitive unit cell, that means the constituent particles will be at the corners. So this is primitive unit cell. Then next we come to body centered. So in body centered, there is a constituent particle. So if you say body centered, that means that you will have a primitive unit cell, and additionally you will have one at the center of the cell. Okay. So when you say body centered, it means that there will be a primitive structure, that means corners, 8 corners, plus there will be one at the center of the body. Then that is body centered. Then what is face centered? Face centered means that you will have constituent particles at the 4 corners and also the center of each face. Now how many faces does a cube have? 6. Right? So a cube has how many faces? 6. So at each face center there will be a particle. So in a cube there are 6 faces. So each face center there will be a particle, and then additionally the corners will be there. So that means according to position of the particle, it can be primitive like this, body centered, face centered. Now there is another one, end centered. Now what is end centered? End centered means that at the 8 corners there will be particles. So end centered means that at the 8 corners there will be particles. And apart from that, any one pair of opposite faces center, there will be particles. So end centered means at the 8 corners. So at the 8 corners there will be particles, and any one pair of opposite faces there will be particles. Right? So that is end centered. So these are the 4 types of crystals based on location of the constituent particle. Next we come to the crystal based on the geometry. Now regarding geometry, these are we don't think only about cube and cuboid. There are some other structures also. So you can see I have drawn, this is based on the geometry. I have drawn a structure. The three dimensions are ABC, what we normally call length, breadth, height, and the three angles are alpha, beta, and gamma. So the three dimensions are ABC and the three angles are alpha, beta, gamma. Now, if you say cubic, that means ABC are equal and alpha, beta, gamma are all 90°. And the examples are NaCl zinc blend. Zinc blend is a mineral of zinc and copper. If you say that A and B are equal, but they are not equal to C, like out of ABC, AB are equal but C is something else, but alpha, beta, gamma are 90, then it is called tetragonal. And the examples are white tin, SnO2, TiO2 and calcium sulfate. You'll have to make an effort to remember this chart, okay? If you say that ABC all are unequal but angles are all 90, like ABC fully unequal, angles are fully 90, then it is called orthorhombic. Examples are rhombic sulfur, KNO3 and BSO4. If you say that A, B are equal but not equal to C, alpha, beta are equal to 90 but gamma is some other angle 120. Then the answers are graphite, ZnO and cadmium sulfide. Graphite, zinc oxide and cadmium sulfide. If you say if you say that ABC are equal and alpha, beta, gamma are equal but not 90 some other value, then it is called rhombohedral or trigonal. Examples are calcite, which is CaCO3, and mercury sulfide, which is cinnabar. Then we come to the next one. ABC are all unequal, alpha, beta are all unequal. Alpha, beta are all unequal and none of them is 90. Okay. So alpha, beta are all unequal and none of them is 90. Okay. So ABC are all unequal, alpha, beta all unequal and none of them is 90. Examples, then it is called triclinic. Examples are K2Cr2O7, CuSO4.5H2O, H3BO3. If ABC are all unequal, alpha, gamma are both 90 and beta is not 120, then it is called monoclinic. Examples are monoclinic sulfur. And another example is Na2CO4.10H2O. Okay, now as I told you that you can classify the crystal system either based on the position of the particles or based on the geometry. So the French mathematician Bravais, he said that total there are 14 crystal systems. So cubic can be primitive, body-centered, face-centered. Tetragonal can be primitive or body-centered. Orthorhombic can be primitive, body-centered, face-centered, end-centered. Hexagonal is primitive. Rhombohedral, which is also called trigonal, is primitive. Triclinic is primitive. Monoclinic is primitive or end-centered. So if you count, there are 14 crystal systems. So these are called the 14 Bravais crystal systems based on the location of constituent particle and based on the geometry. Okay, now just see this, all of you. The topic is number of particles in a unit cell. So let us go to primitive. In a primitive unit cell, I told you there is a particle at each corner of a unit cell. Unit cell is the simplest unit which keeps repeating. So there is a particle at each corner. There are 8 corners, there is a particle at each corner. Now look at any one of these particles. Suppose this one. Suppose this one. Now this particle, I have drawn another image where I am showing that this particle will actually be shared by 8 cells. Just see what I have drawn. The cell which has got that particle, which over here, that is the cell over here, the bottom one. But there are 7 other cells. Like there are total 8 cells which are sharing one particle. So what is this topic? Number of particles in a unit cell. Like if it is a primitive cell, there should be 8 particles. But no. Actually, you have to understand that the crystal is a succession of such unit cells. So each particle will be shared by 8 unit cells. So that means the contribution of each particle, the contribution of this particle to one particular cell will be 1 by 8 because it is shared by 8 cells. So contribution to any one cell will be 1 by 8, and there are 8 of them. So the number of particles in a primitive unit cell is 1 by 8 into 8, which is 1. So this is the first topic. We have learned that depending on the position of the particle, it can be primitive, body-centered, face-centered and end-centered. Now if it is primitive, then each corner particle will contribute 1/8 to that cell. Now there are 8 corners, so 8 into 1 by 8, so there will be 1 particle per unit cell. Now your homework for today, and there is no session tomorrow, so you have to do the homework by 9 p.m. of Monday. So your homework is that just like for primitive, I have calculated that the number of particles per unit cell is 1. So your homework is you will have to calculate and tell me what will be the number of particles per unit cell for body-centered unit cell, for face-centered unit cell and for end-centered unit cell. So for each of these, primitive, body-centered and end-centered, body-centered, face-centered and end-centered, okay? Body-centered, face-centered, end-centered, for each of them you have to say what is the number of particles per unit cell, and that will be your homework for before 9 p.m. of Monday because there is no session tomorrow. So that will be all for this session. Thank you, and I'll end this session now. Bye all of you.